All right, so we've talked about how to get the indices for planes. Now let's do the reverse and see if we can sketch crystallographic planes in a unit cell. So this is going to be our procedure that we use for sketching. And as you might have guessed from the directions, the crystallographic directions, we're more or less going to do the opposite. So it's pretty intuitive. So let's say we have the 301 plane, and we want to sketch it in a unit cell. So these steps that we're going to use are going to be to extract the indices from the parentheses, take the reciprocals, draw the points where the intercepts happen, and then draw lines connecting intercepts to draw our plane. So more or less the exact opposite of what we've done for determining. So I like to, again, always make this table regardless of what I'm doing. So X, Y, Z. I'm going to extract those numbers. So just put it in my table. And then, so that's first one, not super hard. Now I'm going to take the reciprocals. So I've got 3, 0, 1. If I were to take the reciprocals of that, it's going to be 1 over 3, 1 over 0, and 1 over 1. So this is going to be 1/3. This is going to be 1, but the middle one here, you notice we can't divide by a 0. This is undefined. So this is going to be our infinite. So basically, whenever we see a 0, this means that we have an infinity, which means that it doesn't ever cross that axis. So it's parallel to the y-axis, and it doesn't ever cross it. That's what it's telling you. So that gives me 1/3 A, infinity B, and 1C. So now I place those points on the intercepts of the axis. So I've got my coordinate system here, the origin's here. So I'm going to go 1/3 along the x. That's where that intercept's going to be. I'll skip ahead to z here, and it's going to be at 1c. So the intercept at 1c, so one length of that, it puts up here. And then since it never crosses the y-axis, we're not going to make a point. So we're just left with these. And now it wants us to connect those lines. So we've got these two as our intercepts, so we connect them. So far it doesn't look like a plane, and that's because we know that it doesn't intercept the y-axis, so it actually runs parallel. So what we can do is make it parallel to the y-axis by basically extending it along that same direction, parallel to the y-axis. And so we get something like this, and then we can shade it in. So that's all we have to do to sketch it. So pretty much the opposite of what you saw in determining crystallographic planes.